Hello and welcome back. So let's do one more example of solving logarithmic equations, and then we'll move on to solving exponential equations. So here we have the equation 2 log, and now this is log base 10 because there's nothing written there. So 2 log base 10 of x squared, and this is how we write a logarithm squared. This would be the same as just putting the whole thing in parentheses and squaring it, okay? So 2 log base 10 of x squared minus 3 log base 10 of x is equal to 2. And so how would we, solve this equation? Well, we've learned earlier that you can do sort of a substitution method whenever you see things in what looks like a quadratic form, okay? And so here, what we see is, log base 10 of x could be thought of as just a variable. And so if we were to say, well, let's let wrong color here. Let me stay with yellow for now. Okay, so let's let log base 10 of x just be equal to u. And then we could say that log base 10 of x squared is equal to u squared. And so we could rewrite this equation now, okay, as 2u squared minus 3u is equal to 2. And so here we would bring the 2 over, and this would give us 2u squared minus 3u. Minus 2 is equal to 0. So let's look at our factors of 2. It's going to be 1 and 2. And again, here, 1 and 2. This is negative, so one of them would be negative. So a 1 and a 2. And probably we're going to let the 2 be negative because then we could have a 2 times 2. A 2 times a negative 2 would be a negative 4. And a 1 times 1 would be 1. 1 and negative 4 gives us the negative 3. And so we could write this as u and 2u. Right? And then we want, we want the 2u to multiply with the 2 here, right? But we said it would be negative, so we'll put the negative 2 there, and then we'll just put the plus 1 here. And so u times 2u would be 2u squared, u times 1 would be 1u, 2 times u times negative 2 would be a negative 4u, and then the 1u and the negative 4u gives me a negative 3u. Should be going over here. Okay, and then negative 2 times 1 is negative 2. And of course, this is still equal to 0. And so we have that u is equal to 2, or we have, changing the sign, dividing by the 2, we get u is equal to a negative 1/2. And so then right here, all we would have is we could just now plug back in, what u is, which it is, log base 10 of x, right? So then we just put that in, we just say, so log base 10 of x is equal to 2. All right, and so what is that saying? It's saying, well, what do I raise 10 to get x? And the answer is 2. And so we're just saying, 10 to the power of 2 is equal to x. And so it's pretty clear that's just equal to 100. So x would be equal to 100. Here we would be saying, it would be like saying log base 10 of x then is equal to negative 1/2. And so here we're saying, what would I raise 10 to get x? And the answer is negative 1/2. So 10 to the power of negative 1/2 is equal to 1 over the square root of 10. And you could plug that into your calculator. And so that's how we would do those problems. All right, so let's move down now. And now I want us to start looking at exponential equations, okay? So, so here we have a problem that says 3 to the power of x is equal to 2. Okay, so how do we do a problem like this? Well, notice, of course, let me just come over here and do this on the side. Notice that, if I were to say, I told you earlier, if you have log base b of b to the power of anything, it doesn't matter what it is, m, of course that just has to be equal to m. And since exponential functions are 1-to-1, there's only, whatever this is equal to 2, so there's only one value of x that can make that true. And log functions are 1-to-1. And so what that means is we could look at this equation and we can just say, well, so log base 3 of 3 to the power of x has to be equal to log base 3 of 2, right? I can take the logarithm of both sides, log base 3 of both sides, because if these things are equal and there's only one value of x that can make 3 to the power of x equal to 2, then logarithmic functions are 1 to 1. And so when I take these guys, the functions would have to be equal to each other as well. But the thing is log base 3 of 3 to the power of x, well, that just has to be x, right? Because I'm asking, what do I raise 3 to get 3 to the power of x? Well, obviously it's x. And so I have x is equal to log base 3 of 2. And that's going to be typical of exponential functions. You're going to take the logarithm of both sides with an exponential function, and you're going to take the appropriate base so that what happens is that you just get the variable. Okay, so now, of course, you don't know what this is, and you can't really even plug this in your calculator, so you have to do the change of base formula. And so that would just give me x is equal to, and so we'll want to do 10. And so using our change of base formula, we'll just say log base 10 of 2 divided by log base 10 of the 3, right? And so this you can plug into your calculator. In fact, we'll just do it here. And so we have the 2 log base 10 is 0.301. Okay, and so now we'll divide that by the 3 log base 10, which is that. And then when we divide oops, sorry, I went too far, didn't I? Okay, let me fix that. Okay, so it's 2 log base 10, okay, and then divide by the 3 log base 10 and hit equals, and that is equal to 0.6309. So we could say 0.631. So this is equal to 0.631. And if we were to take, of course we're rounding, so it's not exact, but if we were to take 3 to the power of 0.631, let's do that. 3 to the power of 0.631, so 3, and then where's our power here? 3 to the power of, what was it? Let me move this. 0.631, so 0.631, and when we hit that, we come very, very, very close to 2, and that's just rounding error there. Okay, and so that's how we solve exponential equations. We use logarithms. Okay, so let's go down here, and let's do another one. So here's one. Let me do this, I guess, in purple. And so here I have 150 is equal to 5 times 2 to the power of x. So it's just the 2 that's to the power of x, okay? And we want to solve for x. Well, the first thing I could do is I could just divide both sides by 5. And 150 divided by 5 is going to give me 30. So I have 30 is equal to 2 to the power of x. And then what I could do is I could say, well, I'm just going to take the logarithm. If these guys are equal, there's only one value of x that can make 2 to the power of x equal to 30. Logarithms are 1 to 1. And so I'm just going to take the log base 2 of both sides. And so when I take the log base 2 of 30, well, that's equal to log base 2 of 2 to the power of x, which then just has to be x. Right? And so now I have it. I have log base 2 of 30 is equal to x. Again, I'll use my change of base formula. And so I'll just use log base 10. So I'll say log base 10 of 30. Right? We do the argument first, and then we divide by log base 10 of 2. And that would be equal to x. If I plug that into the calculator, calculator always jumps up right in front of the problem. Okay, so let's do that. So log base, so let's do 30. Right, 30 log base 10, and then divided by 2 log base 10. We hit our equal sign, and that gives us 4.906. So we'll say 4.91, and so that gives us that x is equal to 4.91, and that would be the answer. And you can try it. You can, you could say 2, put it in the original equation, 2 to the power of 4.91. You'll be very, very, very close to 30. The only reason you'll be off is because we rounded. Now let me just show you that there's another way, though, that we could have done this. Let me just maybe do this like in red. Okay, so over here, what if I did it this way? I could have said, okay, so I got 150 is equal to 5 times 2 to the power of x. I could have just said, well, let me take log base 2 of both sides starting right here. And I could have said, so log, or, actually, you know what? I'll just say log base 10, actually. So if I say log base 10, And so if I say, just log base 10 of 150 is equal to log base 10 of 5 times 2 to the power of x. Well, so here I'll use my product to sum formula, and I'll write this as log base 10 of 150 is equal to log base 10 of 5 plus log base 10 of 2 to the power of x, right? And so now what I'll do is I'll subtract the log base 10 of 5 to this side, and so that would give me log base 10 of 150 minus log base 10 of 5 is equal to log base 10 of 2 to the power of x. And let's see here. So from this point, what I'll do here, even though this isn't log base 2, okay, so I can't just write it as x. Here's what I can do. I can use my power rule, right? And I can just bring this x down in front. And I can say that this is log base 10 of 150 minus log base 10 of 5 is equal to x times log base 10 of 2. And so now I'll just divide both sides by log base 2. So that would just give me, well, I'll just do it here. So that would just give me log base 10 of 2. I'll cancel this here. And so x would be equal to log base 10 of 150 minus log base 10 of 5 divided by log base 10 of 2. And so the advantage there was maybe a few more steps, but you're in log base 10. And you can just go ahead and plug that right in. And by the way, this is a minus sign, right? So look, I could say log base 10 of 150 divided by 5, which gives me 30. So log base 10 of 30 divided by log base 10 of 2, and you could plug those in to your calculator immediately without doing the change of base formula. Okay, so I'm running out of time. I was going to do one more, but I will go ahead and I will pick this exponential equation up in the next video. I'll see you then.